Hey everybody, so first video of the week, slightly different to the kind of videos that I've done previously. Just thought it'd be interesting to do something slightly different. So what I'm gonna be doing for this video is we're gonna be trying to answer the question, what even is trigonometry? Okay, and the way that we're going to look to do this is I'm going to try and give you three different tiers of answers. Okay, one which is at a very simple level. Okay, a very straightforward, simple answer to what trigonometry is. And I'm going to give you a slightly more involved answer, which goes into a little bit more detail. And then we're going to go for a even more involved answer with even more detail. Okay, and there should be a kind of some part of this that you understand regardless of what level of maths that you're currently studying. Okay, so with that being said, let's see if we can answer the question, what even is trigonometry? Okay, so we're going for our basic answer first of all, the kind of very straightforward, what is trigonometry? Okay, and you could say that trigonometry is the study of how sides and angles are related in triangles. Okay, and we split the focus of trigonometry up into two different sections. We look at one section which is just to do with right angle triangles, and we have another section which is to do with non-right angle triangles. Okay, and one of the things that you would need to understand before you get working with trigonometry is how the different shapes or the different kinds of shapes that you have will impact how you lay out your information. Okay, so our first thing on the left hand side was saying, okay, we're dealing with right angle triangles. Okay, now in any right angle triangle we have this diagonal side, okay, which is always opposite the right angle, and I will do that in a slightly different color. Go for blue. We have a side which is always opposite the right angle, which is called the hypotenuse. Okay, so the hypotenuse is always our longest side. And that's one of the sides that we know, but there are names for the other two sides as well. The other two sides depend on an angle. Okay, and that's why we link sides and angles in trigonometry. Now, where we put our angle will determine what we call the other two sides. So let's say that we put an angle at the top, just here. Okay, and that symbol that I've just drawn there is a Greek letter called theta, and it just means an angle that we refer to. Okay, now if our angle is up here, the name of the side which is opposite that angle is called the opposite. So we had the hypotenuse, which was our longest side, opposite the right angle. And we've got our opposite side, which is directly opposite an angle that we've selected. Okay? And we have a third side, which is this side here, is called the adjacent. Okay? And the adjacent is a side, the word itself just means kind of next to. Okay, so it is the side which is next to our angle, but it's the side that is not the hypotenuse. Okay, so this is kind of our first basic step into thinking about trigonometry. Our triangle has specific, or the sides of our triangle have specific names depending on where we put our angle. Okay, if I was to take our angle theta and I was to put it down in this corner instead, then our opposite and adjacent would swap sides. Okay, because the name of the side depends on where our acute angle is, or the angle that we label theta. Okay. Now, these two things could have been swapped over. If we had another right-angled triangle, our longest side is still the one which is found opposite the right angle. Okay, that's still our longest side. But let's say that this time our angle, theta, was down here. Okay, that would mean that the side over here would be the opposite, and the side down here would be the adjacent. Okay? So at a basic level, trigonometry links the angle in a triangle to the sides around it. And what the sides are called depend on where the angle is. Okay? Now, that's only for right-angled triangles, which is going to be what we're focusing on this week, but we also have non-right-angled triangles. Okay? So you could imagine a triangle that looks a bit like this. Now, we don't have a right angle in this triangle, so we can't label a side a hypotenuse, because even though it looks like this side is the longest, it's not opposite a right angle. So we can't call it the hypotenuse. So what we do with these kinds of triangles is that we just say, okay, if this is angle capital A, this will be side lowercase a. So we form a pair. If this side over here is capital B, this side would be lowercase b. And we'll go for purple. If this side was capital C, this side over here should be lowercase c. Okay? And at a very basic level, or at the starting point for dealing with any kind of trigonometry, how you label your triangles is extremely important. Okay? So, as a basic answer, the study of trigonometry is the study of how sides and angles are related in triangles. How do they link together? Okay? So that's our basic answer. What if we wanted to step it up a notch? Okay. What if we wanted to say, okay, trigonometry, what is it? And we were talking at a kind of high school level. Well, I might say that trigonometry is the study of the ratios between sides and angles in specific triangles, or I might say that it's the study of ratios between specific sides and angles in triangles. Okay, so let's take another look at our right-angled triangle. This side, again, is called the hypotenuse. We need to specify an angle theta before we can say which side is the opposite, which side's the adjacent. I'm going to put my angle down here, which means that the side over there is our opposite. I'm just going to write op. And that the side down here, the side next to our angle, is called the adjacent, because adjacent means right next to. Okay. Now, I said that it was a study of the ratios between the sides and angles. Now, we have specific sides that pair up, okay, depending on what ratio we're looking at, okay. So we could have a ratio of the opposite and the hypotenuse, okay. We could ask, how does the opposite link to the hypotenuse, okay. And the ratio that links our opposite and our hypotenuse, so opposite divided by hypotenuse, is what we call sine, okay? We call it sine, but it's written S-I-N, okay? If you're thinking about this, it's actually written S-I-N-E, but for some reason, convention, I think, we've just dropped the E. Okay, so there's one ratio which links the opposite and our hypotenuse. Okay, and there's another ratio which links the adjacent and the hypotenuse. And that's what we call the cosine, or cos. Okay. And there's a third pair that we've not thought of. There's the one that links the opposite and the adjacent. And that is what we call tangent of theta, okay, or what we call tan. Okay, so we have sine, a cosine, and a tan. Tangent. Okay. So what these three ratios do is that they say that if we know what this angle is, if we know what angle theta is, pretend it was 30 degrees. I know what my opposite divided by my hypotenuse should equal. Okay? So if you got your calculator together, and ta-da, there it is. If we had our calculator and we said, okay, what if that angle was 30 degrees? I pressed equals. I know that whenever I get my opposite and divided by my hypotenuse, I will get 1/2. Okay? Whenever I have my opposite divided by my hypotenuse, if I have an angle of 30 degrees, my answer should be 1/2. Okay? What if we had cos of 45 degrees? Okay, so I know that this angle here was 45 degrees, and I wanted to know what my adjacent divided by my hypotenuse should give. Okay, well, cos of 45 is √2 divided by 2, or 0.707. So whatever my adjacent and my hypotenuse are, when I divide them, I should get √2 over 2, or 0.707. Okay, and what this allows us to do is that they allow us to calculate either a missing angle, a missing side, and figure out what they should be. Okay. Now, there are ways that people have tried to remember these sine, cos, and tan, sine, cosine, and tangent, by thinking about just what sides link with what. And the most common thing is that people will think of so, ka, toa. Okay, kind of like this. And what they will think is that sine of our angle is linked to our opposite divided by our hypotenuse. You could imagine, although we don't tend to write it, you could imagine a little, like a fraction division line in between those two things. So we'd have sine is opposite divided by hypotenuse. Cos of our angle, or cosine of our angle, is equal to adjacent divided by our hypotenuse. Or tangent is equal to our opposite divided by our adjacent. Okay? And we will use these things to think about how to calculate sides and how to calculate angles. And that's mostly what you do with right angle triangle trigonometry. With non-right angle triangle trigonometry, again, let's say we have our non-right angle triangle. We labeled sides and angles. So angles were capitals, sides were lowercase letters like this. Because we don't have like opposite hypotenuses or adjacents anymore, we have slightly different formulas. Okay, and you can derive them. You can kind of start with right angle triangles and arrive with the formulas that you use to do with non-right angle triangles. Okay, And the formulas that you get are slightly different, okay? And they pretty much only feature higher tier secondary school, high school maths, okay? The formulas that you have are that sine of our angle A divided by A is equal to sine of our angle B divided by B is equal to sine of our angle C divided by C. Okay. Now you can see that the two formulas are really quite different, but what they both do is they both link the sides of triangles to the angles that we have in them. Okay. And they link specific sides with specific angles. Okay. There's a second formula that you can use in this, and this one is called the sine rule because it involves sines. We also have the cosine rule, which says that a squared equals b squared plus, that's another b, meant to be a c, c squared minus 2bc times cos of our angle A. This is called the cosine rule. Okay. So what I would say to someone who is in high school and they're perhaps hearing about trigonometry for the first time and they say, what even is it? I would say, well, trigonometry is the maths behind looking at the ratios of specific sides compared to a specific angle. Okay, so if our angle is 60 degrees, we should know what the ratio of two sides is, what one side divided by another is. And if I was explaining it to someone doing higher tier maths, I would say that trigonometry is the study of how we link pairs of sides to pairs of angles and sides to other pairs of angles and sides. Okay? And what we'll see throughout this week is how this information gets used for us to be able to solve problems. Okay? And that's kind of like the staple information that people might see at high school. But if I'm being honest, I think that there's something lacking about the explanation there, because it kind of, although you're saying, yeah, sine is the link between an opposite side and a hypotenuse of a right angle triangle, it's still missing something out. Okay? To where we turn to the next level of our explanation, okay, where we go that one stage deeper and we start talking about what these things actually mean. Okay, so in order to do this, we need to look at some graphs. That's the wrong screen. Let's do this instead. There we go. Right, so we're looking. You might be thinking, we're going to look at some graphs. Where's the graph? Just indulge me, okay? We're going to be thinking about the radius of this circle, okay? And what we're going to be doing is watching to see how this radius will move as it goes around the circle, okay? And as it goes around the circle, you see that red line, okay? That red line is measuring the opposite of this right angle triangle that gets made. Okay? Now, the radius of this circle is 1, which means that the black line, the hypotenuse of our right angle triangle, is also 1. Because the radius of a circle is the same no matter where you go around. Okay? And we can see that as the angle of our right angle triangle gets bigger, we can see that sine, the opposite, also gets bigger until we get to 90 degrees, in which case it's going straight up. And we don't have a right angle triangle anymore. Okay? And as the angle gets smaller, the opposite gets smaller from there. Okay? Now, I don't think I'm going to be able to draw on this. No, I'm not. Boo. Now, if we flick back to our definition of sine, sine is the link between the opposite side and the hypotenuse. Okay. Now, for the diagram that we had here, our hypotenuse was 1, and anything divided by 1 is just itself. Okay. So sine, the ratio, the trig ratio, sine, is a measure of how the opposite changes as the angle changes in a right angle triangle. You can see that this is how it changes. Okay? And we can trace it back the other way. Okay? So as the angle gets bigger, as the angle gets bigger, so does the opposite until we get to our maximum point there. And then the opposite side will get smaller till we get to there, in which case we have no opposite side. The opposite side, that red line, gets bigger and bigger until it gets to -1. And then as we move around back to the side, it gets smaller and smaller again until we get to 0. Now, this here is what we call a sine wave. It's the graph of the trig function sine. Okay? And where we can see that what this is doing is measuring how high up the y-axis the opposite reaches. Okay? We can see that that blue dotted line is tracing how high up or low down, or how far down the opposite side reaches on the y-axis. Okay? But we have other graphs as well. So that was the sine graph. We also have the cosine graph. Now, the cosine graph doesn't measure how far up we go on our y-axis, because the cosine graph looks at the adjacent side compared to the hypotenuse. So in this case, it's the kind of pinky purple line. Okay? And we can see that from the start, our pinky purple line is the furthest away it can get on the x-axis. And as our angle gets bigger, the pinky purple line gets smaller and smaller up until this point where it doesn't exist anymore. It's a 0 length. And as we continue to make our angle bigger, it stretches out to the negative side up until this point where it's as negative as it's going to get. Okay. As we continue to make our angle bigger, the right angle triangle that we get here, the adjacent side of this, which is our purple line, starts to get smaller and smaller and smaller. And as we continue round back to where we started, it gets to the point where we started again. And this thing is called a cosine curve. Okay, the cosine curve is very, very similar to the sine curve. Okay, we're going to flick backwards and forwards between the two. So there's our sine curve. There's our cosine curve. Sine curve. Our cosine curve. Okay. The cosine curve actually is the same as the sine curve, but shifted along by 90 degrees. Okay. That's an important feature that you start seeing in linking sine and cosine when you start thinking about A-level maths or college level maths. Okay. And there's one final one, which is slightly more awkward to explain in terms of graphs. It's called is the tangent function. Okay. Now, if we look back to how we defined tangent, the tangent function was us taking the length of the opposite and dividing it by the length of the adjacent. Now, in this is a bit strange. Okay. As we make our angle bigger, our opposite side gets bigger. Okay? You can imagine the vertical line here would get bigger and bigger. Okay? And we can see that happening as the angle gets bigger, it gets higher up the y-axis, which is what a measure of the opposite is. And as we do that as well, the adjacent side, the measure on our x-axis, should get smaller and smaller. Okay? Now, when we do our opposite divided by our adjacent to measure tan, what we start to get is a number that gets bigger and bigger and bigger and bigger. Okay? You can see that happen here. To the point where it starts getting stupidly big. Okay? And at this value here, we get actually something really interesting happen. We get a value of infinity. We get 1 divided by 0. And if you're interested to see how many zeros you can fit into 1, ask Siri. Okay? Now, something really weird happens here. If I tick over my angle by just a couple more degrees, I have my opposite, which is the measure of how far up the y-axis we have. It's still a positive number, but a measure of how far we go on the x-axis for our adjacent is now negative, which means that when I do something positive divided by something negative, we get a negative answer up until this point here, where we have our opposite, which is 0 because we're not going up the y-axis, divided by 1, which is just 0. And as we continue to flick round, our graph starts to get bigger and bigger until we start having this problem again where we start dividing by 0. And then you might be able to see a pattern of what happens next. We suddenly have a value which is extremely negative again and starts to come up just like we had before. Okay. Now, all of this is very pretty and it's kind of very nice, but does it help us answer that question, what even is trigonometry? Okay. Well, that takes me through to what I would say is our college level answer. Okay. Trigonometric ratios are functions, okay, and they relate an angle between a radius and an x-axis to the coordinate of the endpoint of the radius. That in itself is like, whoa, we're not even talking about triangles anymore. Okay, but have a look. Okay, let's go back to the sine graph. It's this one. Okay, the sine graph measured our opposite. Okay, and in our opposite, that's a measure of how far up the y-axis we go, and that's in part of the y part of the coordinate of the yellow dot. Okay, 0.809 is the vertical part of the coordinate of that yellow dot, the y part of that coordinate. Okay, we look at our cosine graph. The Cosine measures the length of the adjacent, which is the x coordinate of this yellow dot, is down here. Okay, put those two things together, the coordinate of this point, as we trace it around a circle, give us how we define our trigonometric values. Okay. Now, in the space of half an hour, that's quite a lot to take in. Okay. We've gone from saying that trigonometry is how we link some sides and an angle, to thinking about linking specific sides and an angle, to then thinking about actually it's the thinking about the coordinate of a point as we trace a radius round in a circle. Okay. Now, for most of you watching this video, this reasoning of what trigonometry is will be more than enough. Okay. But there are some really, really interesting, beautiful things that happen when we consider trigonometry to be how we trace a circle around, thinking about the coordinate of the end point. Okay. Not just because we get some lovely pretty graphs coming from it. Okay. That's just a bonus. Okay. And anyway, this video wasn't supposed to be something like, this is an example, this is how you do it, go and do it. This is just an added extra interesting thing, okay, that I thought might be interesting for people to see compared to something we would normally do. Okay. Next video that we see, which is going to be how we work with trigonometry, that's going to be something which is much more in line with what we've done before, okay? And we will be starting with the right angle triangle trigonometry, sine, cosine, and tangent. These functions right here, okay? Well, anyway, I hope you found that at least mildly entertaining, or at least slightly informative, even if it's just reminding you what the formulas are that you'll be looking at later on, okay? I'm going to stop there. I think that's enough. I will see you in our next video, which will be on Wednesday, if you're keeping up with the times. Ta-ra.